Hello. A student has asked me to help him with balancing these two equations, chemical equations or reactions. First of all, just a bit of a thing with digital things. There should be arrows to show that we have reaction occurring. Remember, on this side of we have the reactants. On the other side, we have products. So we have two equations. One is a combustion, which is one of the last lessons we just did, and involves a fuel. This time it's sugar and oxygen, and as a product we have carbon dioxide and water. Now, one thing to always remember: do oxygens last? So the obvious thing, we only have really the carbon and the hydrogen, and it really doesn't matter where you start here, you'll end up with the same outcome. Now remember, you just pretend that we've got one of each at the moment. So on this side, we have 6 carbons, all right, and we now need to go to the other side, we only have the one. Remember, you cannot change the formula, so the only way to make 6 is you put a coefficient in front. Acts like in algebra. So we now have our 6 carbons, but it also means we have 6 lots of 2 oxygens or 12 oxygens. So let's fix the carbon up. Now we go to the hydrogen, because remember we do the oxygen last. So on this side we have 12 hydrogens, and on the other side we have, in the formula for water, we have the H2O. Again, you can't change the formula. So we have 12 hydrogens on this side. So how can we get 12 hydrogens on this side? Remember, we can only put a coefficient. So 6 times 2 is 12. So we put a 6 there. And we've done the carbon and the hydrogen. Now let's check out the oxygen. Obviously, all the oxygens are on the product side. So let's find out how many we've got. We've got 6 lots of 2 is 12. And we've got 6 lot of 1 is 6, so 6 plus 12 is 18. So we need 18 oxygen. And as you can see, we already got 6 there. So 18, take away 6 is 12. So we only need 12 oxygens. And of course, they come in pairs. That's called the diatomic. And so we need 6 of those. Now let's just do a quick check. 6 carbons on this side. 6 times 1 carbon is 6 carbons on the other side. 12 hydrogens on this side. 6 times 2 is 12 hydrogen. And oxygen, we have 6 plus 6 lots of 2 is 12. 12 plus 6 is 18. 6 times 2 is 12. Plus 6 is 18. So that's balanced. Let's go to the next one. This is an acid plus a metal. And sodium on its own is very reactive. Again, this one's slightly different. You'll notice we have what's called a polyatomic ion. These are ions that usually go together. You'll learn more about them in year 10. You'll notice they're both on either side of the equation. So we always look at those first. So we got one of each on the reaction and on the product side. So that's fixed at the moment. However, by having one of those, we end up with 2 sodiums. So we need to come back here and we need to have 2. Now remember, we can only change the coefficient. So we have our 2 sodiums. So we've done the sodiums, we've done the sulfates. That leaves us only the hydrogen. We've got 2 hydrogens on this side. Remember, we are taking only one of those. So we only need one of those. And we then have it balanced. So let's check. We have 2 sulfates, one on either side. We have 2 sodiums on the reactant side, and we have 2 sodiums on the product side. And we have 2 hydrogens on the product side and 2 hydrogens on the reactants. And that's balancing a chemical equation.